So that would be part of section 3, and this is actually section 3A, I believe, in the developed with Swift exercise, like the student exercise folder. And the idea, one of the things to actually know is that once you start typing your code, right, or once you start developing an app, almost all of the code you write will come in the form of some instant methods and properties of types, right? And I'm going to, if the particular lingua doesn't, yeah, if the lingua franca doesn't hit a nerve with you, I'll just go to a little depth. But one of the things you remember is once you have, so think of your introduction, the introduction here as an instance, right? Let me see. Okay, let me see. Unit 3. Okay, page 16. Instance methods and properties. Is it? Okay, so when developing an app, right, almost all of your code will come in the form of instant methods or properties of type. So you have your, for example, you type up when you get in Xcode and you begin to type, say in your assistant editor, right? You type in something like introduction, and then you click your dots and you type H. All of a sudden, you have all these, you have your auto suggestion, and you have all of these suggestions. What you have right here on your right is most often going to be a method or some kind of type, right? So the point of this tutorial, or rather this video right now, is actually to just do a little more deep dive into the methods and those properties. I know in previous classes, I had shown us the place of properties and methods, say within your strut or within your class, and what each of those mean and what they are doing there, right? Where properties are literally describing different aspects. They serve the purpose of description. Where, for example, you have a particular instance of a type. Say, for example, a type could be dog, right? And then you have a particular instance of that dog, which could be a Chihuahua, and then it has number of legs, 2, name, maybe bingo, and then it has all the other characteristics, breed, color, and all of that. And then that's your set of properties. And then you come around, and then you have the behavior, or what we generally call the method, right? Or the function within that class, otherwise called a method. And then it's the ability of the dog to bark and to do all the other doggy things that dogs do that other mammalian species are unable to do. So, but what happens when you get into the actual code and you begin to write this code? Because you don't see all of that. You don't see your strut, you don't see your class and all of that. And this is how it displays itself. Like this. So has prefix, for example, is a method, right? And then this is a string, right? But this is a specific instance of a string. A string is a bunch of characters, right? Standing together. And a specific instance of that string is this. So this is an instance of this. But that instance has a couple of properties, right? It has a couple of properties, and it also has a couple of methods, things that it can do. So for example, I could say uppercase dot lowercase. If I want to change this to uppercase, or it has upper and lowercase all over the place, and I want to transform this into some kind of lowercase, I'll just say something like dot lowercase, right? And then it changes it to lowercase or to uppercase or to whatever case I choose to turn it into. So borrowing from what we had done before, at the end of the day, for every type in the real world, there are many actual instances. Now, these are examples of types, right? A dog is a type of animal. A car is a type of its own too. A house is a type. But then um, this is a general or bigger class, right? Which where you have all of the instances around here sharing the same characteristics because they all share the same characteristics as a group, they could be called dogs. They all have four legs, they all bark, they all do all these doggy things, and then we put all of them on that dog because they share common characteristics. So this is a type, and these are all instances. And for each of the instances, right, they could have different property values. They could have, now all of them have the same properties, but they will have different property values. So these are examples of some of their properties: color, size, shape, right? But the values of these properties would differ as you go through each of these instances. So this is your type, and these are the instances. So when we started initially in the class, one of the things we did is we talked about different kinds of types, starting with something as simple as character, CHAR, which is short for char, which is just any letter, in the alphabet, A to 26, if you're looking at just the English alphabet, right? Each of them is a character, and you represent them as char. So that's a type. So if I have char, char is the type name, but an instance of char could be A, B, C, D, E, F, G, H, I, J, K, L, M, N, to and whatever, and maybe everything beyond the 26 letters that we have into some other letters and other alphabets, maybe. So, and then beyond the char, then you have your string, which is a combination of several characters, two or more characters. It becomes a string, right? And then how we represent both the char and the string is we choose the characters or the combination of characters and put them in quotation marks. And then you go beyond that, and then you go to integers, which is a set of whole numbers. And then you go into float and double, which are both decimal after a couple of whole numbers and decimal places after them, right? And then you keep going that way until you get into the more massive and complex types like structs. You go into functions, and you go into classes and all of that. So all of those things, right, are all types. And that's what happens within the computing context. So string, for example, I just mentioned, is a type, right? Hello is an instance of string. So this is an instance. So when I say let hello equals to hello, this is a string, right? But this is a variable. It's like saying x is equals to 2. X and 2 are the same thing. So essentially, it's a string. And this is another string, string right here. Let a different hello equals to hello. But what you have, so this is the string instance, but this is the data that's holding that string, right? So that is kind of understood. But one other thing that happens, right, is all of a sudden, so when I just map a particular type, a particular variable to, an instance, right? Or a particular instance to a value. That's what, if you checked one of the classes we had in the past, it's literally what you call a string literal, because you're mapping a type to a specific value. That's all you're doing. Type to a specific value. That's what you call the string literal, right? But then it's not every time that you see a string literal. And that's one of the things you see when you start coding, right? Which is where all of a sudden you see something like this. And then all of a sudden it's you have this open and close brackets, right? It's not a string literal. Look at your string literals. There's no open and close bracket. It's just standing on its own. But then all of a sudden you see something that looks like a function that is hanging out here. right? It's no longer what you're very familiar with. So this is an example of your string literals, because they use literal values like this, howdy, false. Okay, my false here is supposed to be oh, it's correct because it's a boolean, so it can be false or true, so this is correct. And then this is your integer, right? Your integer is also, so these are all examples of what you call uh, string literals. And what string literal essentially means in a 3-year-old language is that I have a variable and I'm mapping it to a specific value. That's it. I'm using literal values to create instances. So these are all instances I've created, but I created them using literal values. So that's why it's called a string literal. But then there is a different way of doing it, of creating an instance, right, where you don't use a string literal. And that's a case where you're creating an instance without using a string literal is um, is is using what we call initializers. These are all initializers. So like your string open and close brackets is an initializer, bool is an initializer, integer is an initializer. So that's completely different from what you have here. But in either case or in both cases, you are creating an instance. And these are your instance, right? You're creating an instance, but you're doing it different way. You're using literal values here, but in this case, you're using initializers. So the point is, under what circumstances do you use initializers, and what's this whole business about using initializers? So many types have initializers that help you provide more information about your instance. So in this case, right, you're sticking with these literal values because you're not trying to provide more information about your instance. But in a case where you're trying to provide more information about that instance without necessarily going to create a function, that's where you use initializers, right? So I can literally throw in some parameters within this, right, to tell me more about this instance that I've created. So when you begin to code, all of a sudden you might see this, and sometimes you're like, why don't I have the parentheses? Like, why don't I have the secular braces, right? That's the reason why you don't have those secular braces, because they are literally two different things, even though they are creating the same, they are creating instances. And in this case, you can see all the instances that have been created here, right, are all string based on instances that are, created from strings, or simply put, they are all strings. So they are arising from the string type. So many types have initializers. Why do they have initializers? Because initializers help you provide more information about your instance. Parameters help you provide this information. So how do you go about providing that information? So this is a typical example of when I say let's 1 hour later be equals to date, right? Date all by itself doesn't really tell me anything, right? If I just put date here, let's hypothetically say it's just going to pull the date today, but I want to be more specific. I'm looking for something within date. So I'm looking for a time interval, right? 1 hour in the future. That's why I call it 1 hour later. So how do I find that? It's probably maybe 3600 seconds or something, right? And that's how I get that. So I can literally change this parameter and get different values as I change this parameter, right? If I change this parameter, it's not going to be 1 hour later anymore. But that's the difference between a literal, an instance created with a literal and an instance created with an initializer. The point of the initializer is to be able to gather more data about the instance you're trying to create. So the other thing to notice is if we go back here, right, and all of this, everything that is here I just literally sat down today and just pulled them out of the exercise A. So everything is literally in the exercise A. All I'm just doing is just providing context for what's written there and why. And that's why I said I'm going to have to go take each of them and try to provide more context so that when you go through those exercises, you can actually have some context of what's going on there and why. So um so if you look at this, right, your date, let me go back a step, 2 steps backward, right? So when I look at string, right, so this is a specific type. So your type, you can either put your type here or an instance of that type, right? So in this particular case, this is an instance of the type, like date is an instance of the type, right? So I have my date, forget about the parameter inside here, just say date, open and close bracket, right? Your round brackets, date, parentheses, right? And that's all you have. But then notice what's said here, your date, open and close braces looks like a function. It does look like a function because this is usually how you have your func, then date, blah, blah, blah. But notice that it has, there is actually a difference between this. And this is partly why we do those naming conventions, so that once you see something, you are able to immediately tell that, oh, no, this is not a function. Why is it not a function? Because it uses a type name. Type names are usually, you start type names, right? Like if you go back here, you can see these are all type names. And guess what we're doing? We're starting them with capital letters because they are type names. You do not start functions with capital letters. So once you look at this, you should be able to tell immediately, right? Without anyone telling you anything, that this is not a function, even though you have your closing um your parentheses there, your your circle braces here, right? You just know it's not a function. And how do you know it's not a function? Because functions do not start with capital letters. It doesn't mean that it wouldn't work, but conventionally we don't do it. And this is one of the reasons why we don't do it. So that once you see this, you automatically know that this is an initializer. It is not a function. So even though it looks like a function, but it has an important difference. It uses a type name instead of a name beginning with a lowercase letter. Type names start with capital letters. That's what type names do. So string is a type, and this is a string, and it's written like a string. So recall that function names are written based on camel case convention. So this is an example of how you write a function. So if I see this, right, greet, then my capital again, open and close brackets, I know that that's a function. So if you are in an exam situation, right, and then they list a number of these and said, which of the following is a function, you should be able to make that distinction very quickly. Now, they would give you everything that starts with a capital letter, and one of them starts with a small letter, and they're asking which of the following is a function. Of course, the one that starts with a small letter, based on the accepted convention. It's not as if you walk outside a convention, you're wrong, but based on the accepted convention, especially within the Swift community, you start functions with small letters. So hopefully you've been able to understand types, and then you've been able to understand instances, and then you've also been able to understand the two ways through which you can create instances, which is your string literal or using initializers. And then you should have been able to also understand the difference between a function and an initializer. And then very importantly, also why you use initializers is literally when I want to provide more information or context to the instance I'm trying to create. So what similarities do you have between functions and initializers? They both can have parameters or no parameters at all. So functions, you can literally have your braces, right, there without any parameter in it, or you can have parameters in either of the cases. But the original purpose of having those things is so that you can throw in parameters at any time, right, and alter the value of um, of your instance. So you also call them in the same way by passing in required arguments. So usually if you want to call a particular initializer, or you want to call, if you want to call an initializer the same way you call functions, remember how you write your functions and then you come to the bottom and then you have your the values of your argument, and then those arguments pull the call is made to those arguments to supply the values to the function. Same way it happens with initializers. The difference, you use the name of the type when calling an initializer. All right, that's what you do for initializers. In the other case, you go use arguments, but for in the specific case of initializers, you actually use the name of the type. And the initializer typically returns a new instance of its type, because the whole thing about the types and the initializer, what it does, it creates an instance. That's what its focus is, to be able to create an instance. As you alter the value of the parameters in a specific instance, it creates another instance. So now, I like us to now pay attention. We've talked about types, we've talked about instances, but there's also something we now call instance methods. After I have created a type, e.g., dog, and then an instance of that dog is a Chihuahua, right? But that Chihuahua has specific properties and characteristics that I can exploit, right? So that's where the instance method comes in, right? So instant methods are literally functions defined as part of a type, right? Strings have many instant methods. So the string is an example of a type. It has many instant methods. So these are examples of an instant method. And at some point, uh, in discussing this today, we're going to go to the point where I begin to make a distinction between properties and methods again. I know you've heard that before, but like I mentioned, I'm trying to go deeper so that when you start typing and you're doing all of that, while you're even typing, you are able to make a distinction between what is a property and what is a method and all of that. And then if you're not sure of information about the properties and the methods, to also show you ways to be able to fact check or look for information about those on the fly while you are coding. So these are all examples of methods, right? And like for example, append, it adds a string value to another string. Let's say you have a string that says something like Colombia is an awesome place, and then you have another place that says for Jackson, uh, for Jackson is in Colombia, right? So you can use append, that method, to join Colombia is an awesome place, and for Jackson is in Colombia. That's like what you use append for. So elements, to if you want to check if two strings, for example, are equal, the two strings I just mentioned now, you can use element equal to check whether they are equal. And then the particular one we're going to look at an example of is the has prefix. And the interesting thing is, for each of those types, right, even before you code, you can literally go online and just look for string methods, right? There are all kinds of documentation that will show you the different string methods, and then you can read them up. And then you do that for maybe char, and then you do that for for classes, and then you do that for struts. I mean, you do that for everything that you so that you get more acquainted and aware, and you can actually see examples of how they are used. So this is literally how you declare instances, right? So what has prefix method does, I think we've probably used it in one of our classes here, is you are essentially trying to find if a string begins with another string. So if you want to find that out, you literally invoke the has prefix method. And essentially, this is what it happens once you, so this is the function, um, this is the function in the hood. So I'm saying this is not what you see in the hood. Remember, a lot of times when you see a property or a function, right, it's being written behind the scene, right? And you just call it up by using something else, right? But this is the original code, as it were. So and it's a function, but it's somewhere behind the hood. Eventually, in the next slide or two, I think it's the next slide, I should be able to show you how to call this function, right? So for each of these methods, right, there are code snippets, right, that are in the library, so that whenever you want to call each of them, you automatically call them. So this is an example for this. So all it's just saying is this function has prefix underscore prefix, right? And you put a string here. And what string are you going to put here? The string you're going to put here is the prefix you want to test. And I'm going to show you what I mean when I say the prefix you want to test. And then the Boolean will be the output, because you see this arrow sign simply says, when I do this operation, this will be my output. It's either going to be, because it's a Boolean, it's going to be a true or a false. So when we go here, excuse me, instant methods are called using a period, right, after the instance, followed by the method call. So this is your method call. This method call calls this function behind the scene. So this is an example of this. Literally, is an example of the use of has prefix, for example. So we have two declarations, right? Let introduction equals to, so this is a constant, right? Let is a constant. Is, we're either using let or we're using var. Let is a constant, var is a variable. Let introduction, this is the name of your variable, right? Equals to this, right? What is this? This is an instance of a type. What is the type? The type is string. So that's why it says consider two string instances. So that's why both of them are string instances. So introduction is equals to this. This is an instance. Alternate introduction, that's another introduction. That's how they decided to name it, because you can name it anything, equals to once upon a time. So you have two string instances, right? Introduction and alternate introduction. Now, the point is, I'm writing a piece of code, right? And I'm trying to figure out some piece of code, some declaration somewhere, right, called introduction. Does it have, let me go back and show you what I was talking about. Does it have a certain prefix? In other words, in the beginning of the sentence, does it have a specific 2 or 3 letter word, right? And in this case, it was. If you look at this, it starts with it was. So yes, it was. It was. It was. So just by typing introduction dot, that's how you call it, dot has prefix. And what we are doing here, this is literally a method, right? And then you enter what you're trying to test for or check, which is your instance of a string, and then it returns a value for you, yes. That's the output. If you run that on your playground. Then you go to introduction dot has prefix, right? And you try it wasn't. It wasn't isn't here, so that's why it's going to return a false for you. If you go do the alternate introduction dot has prefix, it gives you it was false because there's no it was here. There's no prefix in this sentence that says anything about it was. You do alternate introductions dot prefix because all this is doing is checking here if this does exist. The first three letters, and in this case is two, and I think it's a maximum of three or something. You need to double check that. But what it checks is the first three words to see, and you can test for those words, right? The prefix, you check that, and in this case, it also says false, and it's true in all of this. The only time it's true is here, and it's false all over in this. So that's literally how a method works and what it does. Okay, no, this is known as, sorry, this is known as calling. Let me fix this on the fly. So it says what we just did right now is known as calling a method on an instance. So you're calling this method on this instance. You have called has prefix on introduction. That's what we have done here. That's the technical way of saying it. You've called has prefix on introduction. And you've also called has prefix on alternate introduction. So, and this has to do with type safety. So has prefix is a string instance method, which we have pointed out. I've told us what a string method is. I've told us what a type is, and I've told us we have a type that's called string. But in this particular case, we have an instance of that string. That's why we call it string instance. But that string instance has a method, right? And this is one of the methods that we have. So has prefix is a string instance method, so you can't use it without an instance. So you can't just wake up and type dot has prefix. It doesn't mean anything, right? It only has context if there is introduction. So if you were to strike this out, right, dot has prefix doesn't mean anything, right? It only has context with regard to a string. That string doesn't have to, that instance doesn't have to be introduction, but it has to be some string. It could be any other word here, but provided it's a string. The rule number two, and if you removed this and just type dot has prefix, open and close brackets, if you are in playground, it's going to give you an error, and which is one of the things in the exercise, right, where you were asked to remove the backlash, which commented it out. Once you remove it, then all of a sudden it gives you an error. So, and that's Swift's way of protecting itself so that you don't do like stupid thing, which is the whole point of type safety. So secondly, you can't use an instance method on an instance of the wrong type. So notice if I declare let number is equals to 42, I don't even need to type int, because another way I can do it, I can say let number equals to int. So notice that what happens is if you can use a type or its instance interchangeably, right? So in this particular case, I can say let number is equals to int, right? Capital I, N, and T, right? But if I don't put capital I, N, and T, just because I put 42, Swift automatically knows that I'm talking about an int. So having declared that N is an integer, right? If I turn around and now say number dot has prefix, I'm going to get a huge error. Why? Because int does not have a method that is called dot has prefix. This is a method of string. Does that make sense? I hope I'm not blowing um, past without making creating understanding. But if you lost me anywhere, just you can just type and let me. If I have to go back, I would go back. Um, okay, so essentially you can't use an instance method on an instance of the wrong type. So there are different types. Each of those types you can create an instance in them, but then the methods of one instance can be used for another instance, which is what's going on here. So properties in Swift, each instance has one or more pieces of associated information. Now, remember, I'm done with talking about methods. I know I've talked about methods and properties a lot in the class, but I never really came at it this way. Now, I'm done talking about instant methods. Now I'm talking about instant properties, right? Instant properties. In Swift, each instance has one or more pieces of associated information. What does that mean? It's in layman's language, it just means that every instance that you pick up, right, has a bunch of characteristics that it has, right? That's identifying characteristics. So, like I talked about, a dog is a type, and then there are different kinds of dogs, dog breeds. There's a Chihuahua, there's a German Shepherd, there are all of these ones. But each of them has a bunch of characteristics, right? And values. They have their own associated values. The values, even though they might have the same properties, but the values of those properties are different. Their color might be different, their shape might be different, their size might be different. A German Shepherd and a Chihuahua would both have size as properties, but their values are definitely going to be different because they are two different breeds. When I fill out a form and one of the fields in the form is breed, the breed is going to be different because one is a Chihuahua, one is a German Shepherd, right? So that's literally so in Swift, each instance has one or more pieces of associated information. These values are referred to as properties. So they all have a bunch of properties, even though their values could be different. So, how do you? This is the way behind the hood. That's the way properties are defined. They are defined as variable. And in this particular case, I'm talking about a specific property, which is empty. And I'm going to show you how it's used for strings, right? So this is specifically talking about a particular property, string property that is called is empty. So what's going on here, right? So this is the name of the property in question here is empty. The property type, remember it's empty. You're trying to find out whether it's empty or it's not empty, right? So the type, as you can see here, is a boolean, right? Um, it's also a variable. Notice we used var instead of let. And then the only other thing you see here is some kind of read-only property. And usually for you can have two of those for this specific application. It can be either a get, and a get literally means that you're trying to get the property, you're trying to stretch out your hand and get that property, or you want to set a property where you're trying to assign a specific property, like something like make a change to a property. So properties are called by using a period, just like your methods. You also call a property by, immediately after the instance, you put a dot and that dot, right, begins to call that property. And that's why once you put a dot and you type one or two of the following letters, automatically there's an auto suggestion that leads you into seeing what that property is. So properties are called by using a period after the instance. Already know what an instance is, followed by the property name. So let spring break equals to this. So this right here is a string, right? But let's say I want to empty this string, right? I'll just say string property dot is empty, right? Now it's checking, is this like I mentioned is a boolean, right? So all it's doing is it's checking whether the string property. So this spring break actually has something. This is the specific instance, right? So it's asking is, think of it like this asking is spring break empty, right? And the output is going to be false. Now, this is a second arrangement where you have let nothing equals to a null string. In this string, there's nothing there, right? Then if you type nothing dot is empty, which is literally like asking is nothing empty, and if you type this into your playground, it's going to uh so did I lose anyone? Oh, I think I did. Yeah. I have a second screen. Just hold on. Let me go back. I think something happened because I have a second screen. I'm just seeing what you guys are talking about. Can you see me now? Okay, this is what I was talking about here. I'm sorry about that because I moved, but I think my screen probably froze or something froze along the line. So let me go back and I don't know where did you lose me? Did you lose me here or here? See here? Can you hear me? Did you get this? If you got this, just say yes. Okay. Type safety. Oh God, I'm sorry. I just kept talking. I didn't know I had lost. Okay, let me start here from type. Okay. So Uh, I don't think it's you because I looked at my second screen when I saw the message and I saw that it was frozen even though the other screen was moving. Okay, let me start from here. So I'm gonna start from type safety. So what I did say was methods and type safety, and I said has prefix is a string instance method, which we already agree on because we did that in previous slides, right? So it's a has prefix is a method, is a specific method, but it's an instance method. So you can't use it without an instance, which is the point. And I was saying, ideally, you're going to write something. Let's say this is your instance, right? Introduction. And I think we talked about this. This right here is our instance introduction, right? So this is the introduction here. This is our particular instance of that string. So if I come here, right, and then I came here and I listed this, right? This is when I'm making a call to has prefix, right? Let's just say I'm like, I can just come around here and just delete introduction and just write dot has prefix. I was saying that the way Swift is configured, it's going to throw up an error, a huge error, because for it to work, it always has to be associated to a specific instance. And that instance, in this case, if you strike this out, which is why I put the arrow, if you were to strike that off, you're going to get a big arrow. So you can't use it without an instance. The second rule, and this is because of type safety issues, is I say let number equals to 42. And what I had indicated is without saying anything, right? Like is a person that is not skilled in this art will come here and they're like, I don't know. I don't know what kind of type it is, right? But because you have been through this, you automatically know what type this is because, and I said you can either use an instance, this is an instance of an integer. You can either use an instance or you can use the type itself. So you can say let number equals to int, int, capital I, N, and T. You can say let number is equals to int, or you can use the instance. The system understands it the same way. Let number equals to 42. So without putting int here, right, the system already, or Swift already knows that you're talking about an integer by just putting in a whole number, because an int is um you know represents a whole number, but this is a specific instance because one can be an int, two can be an int, four can be an int, 100 can be an int. But in this place, this is a specific instance of that, of int. So that's what I'm saying. So now, having defined this instance here, right, you know that this is an instance of an int instance. Now, if all of a sudden you now come write a number which is an int instant and say dot has prefix, right, it's going to throw up an error. Why? The reason it's throwing up an error is because it has already seen that number is, you've defined it here as an integer, not as a string. In this case, we know this has been defined as a string. But in this particular case, you've already told the system here, right, that this is an integer. So if you go use an has prefix is a specific method for strings. If you go back, I showed us somewhere here. This is where I gave us examples of some methods, right, that are specific to strings. Strings have many instance methods. Integer does not have has prefix as a method. So that's why I go back here. The point being that if you now put an integer dot a method, right, that is a string method, it's going to throw up an error because they are incompatible. Is anyone lost? If you're lost, just type lost. And I'll go back to it again. Okay, my assumption is nobody's lost. So now, so having finished with method, right? I'm moving to properties. And I said properties and methods are twins from the same mother, right? But I've talked a bit about methods. I'm going to get back to it at some point. But let me focus on properties now. So in Swift, each instance has one or more pieces of associated information. And when I talked about that, I said, hey, I have a type that's called a dog, right? And there are different instances of dogs. I could have a Chihuahua, I could have a German Shepherd, I could have a Bulldog, blah, blah. They're all instances of dogs. But what makes them all dogs is that they have a set of defining characteristics that is unique to them. That's why we grouped all of them and we call them dogs, right? Now, those pieces of associated information that is common between them is what you call properties. So different instances typically have the same properties, right, at a global level. But then they could have different values, same properties, different values. Just like I can feel name, email address, home address, phone number, blah, blah, blah. You can use it for 300 students, but the values that those students fill in the fill out sections will be completely different. Same thing here. So, and I've started talking about a specific, there are different kinds of properties for strings because we are talking about strings specifically here. And one of those properties of string is called is empty. And I was saying that behind the hood, right, there's a function that drives is empty. Whenever you go see something does is empty, right? That's a function call. You're calling on this function, which is behind the hood, typically in the library, right? So, and I was saying what's going on here is this is the name of the property bool here with the uh, colon here and bool. It's essentially telling you that this particular property, right, is of the type bool. And then the get that you see here in curly braces is essentially telling you that what I want to do is I want to get the property. I want to get that property because for me to be able to decide, remember bool is true or false. For me to be able to decide whether it's true or false, if that property is empty, I have to be able to make a check, right? So that's why I have get. And it's some kind of what you call a read only property. Is either you're going to get a get or a set, right? So in this particular case, what we have is a get. So it's just saying that you can get the property. So what else? So then the next thing I talked about here was properties are called by same way like methods, right? Properties are called by using a period. So once you type an instance as you're coding, blah, 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 you type something, right? And you want to get a property, you click dot. By the time you type one or two of the letters of that string, all of a sudden it pops up a couple of options for you. You choose what option you want to, and then you tab, and then it shows up there. So this is an example. Let's say we're declaring let's spring break equals to. So spring break, I can tell that this is a string. How is it a string? Because I can see what's written here. This is how you write strings. So I automatically know, even without you explicitly declaring that this is a string. I know it's a string. Why? Open and close quotation marks over a bunch of characters right here. So I know that this is an instance of a string. So what I'm trying to do here is I'm trying to check whether this particular string break is empty. But we can see it's not empty here, right? But we want to do a computational check. We now say string break dot is empty, right? It will return false for us because it's not empty. It has something in it. So that's done. What if I have another string, right? String instance. And I say nothing is equals to, and I deliberately keep the value as null, nothing here. If I type nothing dot is, and I apply the method is empty, it will turn up as true because this is empty. And that's the use of it. Now, talking about it here looks simplistic, but then when you start coding, there are specific instances where you want to find if a particular string is empty or is closed, and that's why you have all of those kind of methods and properties. So same thing, just like the methods, we also talk about properties. Is empty is a string instance property. So you can't use it without an instance. Same thing. So you can't just go about and just type dot is empty. It's going to throw up a fit and give you an error value. So you can't use an instance property on an instance of the wrong type. Same thing I talked about the last time. You can't just go around combining methods and properties for different types. You have to be sure what properties you're using. So a property gives a way to get or set a value that is part of an instance. So each property can have a different value. We already know all of these, different value for that property. So these are, for example, two different instances. Notice that all of them have the same properties, but guess what? Their values are completely different. This is 2 years, this is 3 years. The name Bingo Baylor, different things, right? But all of them belong to one one class, which is or one type, which is for in this particular case, say dog. So so this is an example of what you tend to see happen, right? If I was going to declare this, I'll say strut, and I think we've done all of this before. So I can, instead of saying, remember I was telling you that once you define or declare a variable, you can assign it to either the type or the instance of that type. So I can come in here and just put doggy is blah, 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 provided I put it in open and close quotation marks. It's going to be the same thing, but the only thing is going to be more restrictive. But because I'm trying to create a generic system here, because this is the type, right? I decide to use the specific type. So this is a type. These are types within a type, right? So with that, I can now come here and create an instance of a dog. So I can come here and create dog 1, dog 2, dog 3, and create a million dogs, right? And all I need to do is come inside the parentheses here, and then I can now define the parameters specifically. The name, my name is the name of this dog 1 is going to be this, their age is going to be this, and I do that for all of the dogs, and then I run it, right? And the instances of those dogs have all been created. I can now come in here and use a code snippet like this. Dog 1, I want the name, I want the age or whatever, right? And all of a sudden, I can call it. So say dog 1, if I want to find out the age of dog 1, right? After I have defined it here, all I need to do is dog 1 dot age, boom, I have the age of dog 1. So that's the whole point of properties and methods, right? So, and my whole point is for you to be able to understand what's going on when you're typing and then you click that dot, right? It's throwing up either a property or a method, property or a method, property or a method. So the next thing at some point that we're going to do is the distinction between a property and a method, which by the way, you already know, but then there are further things we need to talk about. So property, so when you see some of these, is it a property or a method? How to tell? Now, dot has prefix or dot is empty, right? This clearly from the previous slides, right? We know that this is a method, a string instance, a method of a string instance. And we know that this is a property of a string instance. So the test one is you want to ask yourself, right, when you're trying to determine whether something is a string or a method, you want to ask yourself, do you need to pass in information? And I'm talking about those parameters. Remember how we pass in information into a system. If the operation you want to perform needs extra information, then it must be a method. Then, right? So if the operation you want to perform, right, needs extra information, then it must be a method since you can't pass argument to a property. So notice that, remember in many seasons back, right, I was telling us that what a method does is that it helps you manipulate data. And usually that data is collected as parameter. So when you collect data sorry, when you collect data as properties, right, you pass that data on to the method, and what the method does is to help you manipulate the data. So therefore, if you're looking at two things and you're not sure whether they're a property or a method, right? No, just know that if that operation you want to perform needs extra information, is trying to collect extra data to do what it needs to do, then you're probably most likely dealing with a method. Since you can't pass, you know, arguments, you can't pass arguments to a property, right? So has prefix must be a method because you need to pass in the prefix you are testing. And this is an example. Notice that at some point we had to pass in some prefix, right, to be able to help us check something. So that's an example. But when we were doing empty, we never tried to pass in any data to it. And that's how properties behave. And then this is your method, right? We needed to pass in some kind of data in there. So the test two is if the operation has side effects, right? Things that happen that have nothing to do with the return value. So when you run an operation, a lot of times, right, you have a return value in. Now this has ended here again. It's empty. Test two. So if the operation has side effects or things that happen that have nothing to do with the return value, when you set up like your function, often you end up with some kind of return value, right? Often, but not all the case. So if the operation has some kind of side effect, notice what happens. So for example, a string has a method. There's a method, strings have a particular method called remove all, which empties the string. So for example, if I have something like this, var, I declare this, magic is equals to this particular string. If I use this method dot remove all, guess what's happening? My output is going to be empty because it has removed. So anytime you are working with um, any particular element like this, and it results in some kind of side effect, like it's deleting something, is increasing something, is changing it to what do you call it? Uppercase, lowercase, blah blah blah. Once it's having any kind of those side effects, just know that what it is that you're dealing with at that particular point is a method. And then the other part is once you're typing, like your coding and all of that, one of the things you run into is you might run into a couple of properties or methods, right? That you actually have no idea what they are. Because once you just type, say you type .p, all of a sudden all these things will come up. Let's say you have no idea, but you're interested in finding out, or you're familiar with one of them, but there are so many other options. But like I told you, it's like learning a language, something that you're not familiar with, you're never going to be able to understand except you kind of encounter it. That's what's happening here. That's where your documentation becomes very important. And that's what a lot of skilled programmers, seasoned programmers do. And that's like reading up documentation, understanding what things mean. Just like learning literal languages, that's how you build your vocabulary and that's how you become more fluent in what you're doing. So the instant methods and properties of a string are the API of that string type. So when you click that dot, right, those instances, the methods and the properties are literally the API. If you remember when we did the Bougie bot app, when we made that thing dance, and all of that, all we were doing was just playing around with the API. And you notice in each case it was dot something, dot this, dot that, dot this, and literally those things that you were seeing dot and dot of that were essentially methods and properties, right? So most of what you're going to be doing when you're coding is about what we are studying today. That's what you're going to be dealing with once you are coding. So I listed a couple of ways. One of those things is you either literally remember parts or the whole of the property you want to call up, right? That's one way. And all you do is you dot and then you start typing, and all of a sudden it will create an suggestion, and then you go to what you're looking for. Or another way is literally go highlight the particular term that you don't understand, and then click option. You click option and click on that word or the phrase at the same time, right? And then it will throw up some kind of documentation for you to read and understand. And in some cases, we actually have examples of how that particular property or method is used. You can tell from the documentation whether it's a property or it's a method, and then it will show you what it's used for, what it does, and in some cases, it will actually show you examples of how to use it. The other way is to use your quick help inspector, and you can find it on the menu by going to click view inspector and then show quick help inspector, and then you can find it from there. So that's essentially that part of unit 3. So for me, going forward, like I mentioned to you, even though the exercises are supposed to be strictly for students, I'll try to begin to build a library. And as you would agree with me, those things would take some time, but I'm going to build them. If it's something you are interested in, you can always go back to that channel and you will see more information on. As we get more information, we're going to throw them in there and we'll keep building the library and making it better. So does anyone have any questions at this small points? Lost you, need more information? I think I'm done with the slides. That's all. So I'm gonna throw in um those examples for us, and then um okay, yeah. So I'm gonna throw in those. Expect the vouchers. I'm gonna get them in. Endeavor to take the exams within 30 days or max 60 days. But I think it's in your best interest actually to take it as quickly as possible before um, a lot of the knowledge you have dissipates. Especially in an exam context. So that would be about that. And then I would provide you more information as it becomes available in terms of the other aspects of the course, the second and the third rails. And like I mentioned, keep an eye on the channel. I will be working to put in more information that could be helpful in your journey of becoming a better programmer.